Welcome to my Key Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. In this problem statement, there is a hexagonal prism, 25 sides of base and 50 axis length resting on HP on one of its corners of the base such that the two base edges containing the corner on which it rests make equal inclinations with the HP. Draw the projections of the prism when the axis is inclined to HP at 40 degrees and to VP at 30 degrees. So if you look at the problem statement, we can understand that the type of the solid given to us is a hexagonal prism, and then it is resting on one of its corner such that the two edges containing this resting corner are making equal inclinations with respect to the horizontal plane. So this is the initial resting condition. Next is with respect to the inclination. So the axis is inclined to HP at 40 degrees and to VP at 30 degrees. So obviously in the front view of the first position, which is having the axis length of 50 is going to reduce its dimension in the second position when it appears to be inclined to HP at an angle of 40 degrees. But when you measure the axis in the top view, we are going to see the reduction in the dimension of the axis. And that axis is the condition which is taken for inclination with respect to the VP. And hence, it becomes a beta angle problem. So we need to construct a beta angle here. So now we'll see how to draft the solution for this problem. So let us begin by drawing the XY line of thickness 0.18 mm. So let us initially draw a line of any arbitrary length and then annotate the line as X and Y and also the reference planes as VP and HP. So this is the reference line XY and then the plane VP and HP. We'll construct the top view of the hexagonal prism. So let us select the line of thickness 0.50 mm. Let us draw the first edge, which is 25 and the angle is 0. Next, the edge length is 25 followed by the angle which is equal to 60 degrees. Next, the edge length is 25 and the angle is 60 into 2 followed by the edge length which is 25 and the angle is 60 into 3. Next, 25 followed by the angle which is 60 into 4, and then we'll conclude by typing the edge length as 25 and the angle as 60 into 5. So with this we complete the top view of the hexagonal prism. To get the axis point, we shall draw the diagonals. So let us draw the diagonals connecting the corner points, and the intersection of all these corner points is the origin of the axis. So let us draw the projection line from this intersection point to intersect the XY line, from where we need to draw the axis of the prism. So the axis can be drawn by using the chain line, and the length of the axis is 50 mm. So this is the reference for completing the front view of the prism. So now let us draw the projection lines from each of the corners. Ensure that all the projection lines from each of the corners are 90 degrees and they are intersecting the XY line. So now we will annotate the top view. So let us tell that it is resting on the corner A1, but since it is the top view, the corner A1 is not visible, but the corner A of the top face of the prism is visible. So let us enter A and A1 inside the bracket. And similarly, let us annotate all the other corners. And this is the axis, that is O and O1, where O is the center of the top face and O1 is the center of the bottom face of the prism. So now we'll complete the front view. So for that, let us select a line of thickness 0.50 mm. So from D to CE, then to O, and then from O to BF, and then to the corner A. So this marks the bottom face of the prism. So now the height is 50 mm. So draw the line in such a way that it is having the endpoints from each of the projection lines. Now let us draw the rectangular faces. So totally we'll be able to see these three rectangular faces in the front view for the hexagonal prism when it is resting on one of its corners as shown here. So now we'll do the annotation for the front view. So let us first complete this axis line. So this is O dash and this is O1 dash. The copy is on. So keeping A1 dash as the point of reference, let us just move this towards the right hand side of the XY line. So now we have to rotate the base of the prism in such a way that the axis will be appearing to be inclined at an angle of 40 degrees. So for that, let us select the base, that is A1 dash, and then D1 dash as the reference points, and then incline this at an angle of 90 minus 40 with respect to the HP. So now you can just see that if I use the extend to next option and extend this axis line and then measure the inclination, it is equal to 40 degrees, which is as per the required condition. So this completes the top view of the hexagonal prism with its axis inclined at an angle of 40 degrees with respect to the HP. So now we'll draw the top view. For that, let us select the projection line of thickness 0.13 and draw the vertical projection lines from each of the corners of the top face of the prism downwards. And then similarly from each of the corners from the bottom face of the prism, let us draw the projection lines downwards. Now let us draw the top view of the prism by selecting the line of thickness 0.50. So now let us complete the top face of the prism, which is completely visible to the observer. So let us start from the corner A. So from the corner A to the corner B, and then from the corner B to the corner C, and then the corner D is here. So the point of intersection of these lines. Then from corner D to the corner E, and then corner E to the corner F, and back to the corner A. So we can just trim this corner D projection line also here only. So it is not required to extend this till here. So now let us complete the bottom face of the prism. So for the observer, when he's looking from this direction, the farthest corner point is A1. So from A1, the edges will be invisible. So let us select the dotted lines. So from A1 to B1 it is dotted, and also from A1 to F1 it will be dotted, and also this edge, that is A1 to A, will also be dotted. So next we'll complete the other outer edges which are visible to the observer. So from B1 to C1, C1 to D1, D1 to E1, E1 to F1. So next let us connect the corresponding parallel edges, that is from D1 to, okay, this is E1, so E1 to E, and then the point that is F1 to F is overlapping behind this, so no need to show this. Then we have got D1 to D. Similarly, we complete the top view of the hexagonal prism. Now let us annotate this. So this is the corner A, corner B, corner C, corner D, corner E, corner F, corner O, sorry, the axis point O, and this is the axis point O1, and then this is A1, corner B1, C1, D1, E1, F1. So when we use this position for the next position inclination, so we will not be having this as a discontinuous line. So what I'll do is select the trim option and then make this a separate line so that I get the point O1. So from D1 to O1, I'll make this a separate line, and also similarly here I require the point O1. So what I'll do is I'll just use the trim option. So let me select the line, dotted line. So from O to A, I'll make it a separate line so that I'll be getting the point O. Okay, so with this, we have completed the top view of the hexagonal prism when its axis is inclined to the HP at an angle of 40 degrees. So now we need to construct the beta angle. So for that, what is the procedure is, let us first measure the axis length in its first position, which is equal to 50 mm. And then the axis length in its second position. So the distorted axis is going to measure around 38.3 mm. So this two data are required for us to construct the beta angle. So now let us select the line option of thickness 0.13, draw a line of any arbitrary length. So let it be a continuous line, and then select the line option again, and then let us draw the line measuring 50 mm in length, inclined at an angle of 30 degrees, which is given in the problem statement, 30 degrees with respect to the VP. So from the end point of this, let us draw the locus of O1, and then let us consider the arc by center point, and then draw the arc whose radii will be equal to 38.3 and intersect that with the locus of O1. So from the point of intersection of the locus and this arc, let us draw the line back to the point O, and that is the this inclination of this line is going to be the beta angle, which is equal to 41 degrees. So 41 degrees is the beta angle, and the angle 30 degrees is the given angle. So to annotate, this is the point O, and this is O1, and this is the locus of O1, and this is O1 from the second position. So for reference, let me call it as O12. Okay, so this is the construction of beta angle. So now we are going to consider this beta angle for the position with respect to the VP. So let us draw a line which is inclined to VP at an angle of 41 degrees. So on this 41 degree line, we are going to align the axis of this hexagonal prism. So for that, let us select the prism, select all the outer edges first, and make it a rigid set. And select even the annotations. So now let us select the move option and ensure the copy is on. So keeping O as the reference point, let us move this on the 41 degree line, and then let us rotate, keeping the axis is inclined to VP at angle of 30 degrees, but appears to be inclined at an angle of 41 degrees. That is the beta angle. So now let us draw the projection lines to get the front view of this condition. So let us select the line of thickness 0.13. Now let us draw the horizontal projections from the top face of the prism in the front view. So from corner A, let us intersect that with the corner A of the front view, and then corner B is on this line, corner C will be on this line, corner D is on the topmost line, corner E is on the projection line of C as well, F is on the projection line of B, and then O is here. So use the trim option to trim the lines which is not required for the construction. So now these are the points of intersection. So for the observer, the corner F will be the farthest corner point. So we have to understand that all the edges originating from the corner F will be hidden. So with this um, input, let us try to complete the front view of the top face of the prism. So first let us select a line of 0.50 mm. So let us begin with the corner A. So from corner A, we have to join the corner B, and then corner C, corner D, corner E, and then corner F, and then back to corner A. But however, this corner F, and that is the lines originating from the corner F, will be dotted. Okay, so now let us annotate this. So this is the corner A dash, corner B dash, and this is the corner C dash, corner D dash, corner E dash, and this is the corner F dash, while this is the point O dash. That is the center point of the top face of the prism. So now let us complete the front face of the, the bottom face of the prism. So let us select the line of thickness 0.13 mm. So anyways, the corner A1 is on the XY line. So from B1, F1, let us draw a line. Similarly, from O1, let us draw the horizontal line. C1, E1, let us draw the horizontal line. And D1, let us draw the horizontal line. So all these lines will be either 0 or 180 degrees. So from the corner A, intersect the XY line because it is on the XY line. And then from the corner B1, so we'll use the trim option simultaneously in order to avoid the confusions. So next we have got the line from corner C. So with this we have finished the intersection of the horizontal and the vertical projections from the bottom face of the prism. Now let us construct the bottom face. Select the line of thickness 0.50 mm. So let us begin with the corner A1, which is here, and then corner B1, which is here, and then back to the corner C1, and then corner D1, then corner, okay, so corner E1 will be here. We have to extend this, and then corner F1 is here, and then corner A1. So we'll just extend this projection of the corner E1 to meet this horizontal projection. Okay, so now we have completed this. So we'll go for the annotation, and let us annotate. So this is the corner A1 dash, while this is the corner B1 dash, and then this is the corner C1 dash, and then this is the corner D1 dash, E1 dash, F1 dash, and this is the axis origin point from the bottom face, which is O1 dash. So now let us connect the axis line first. So take the line of thickness 0.13. Let the line type be the center line. So from O1 to O, we are going to draw the axis line, and then we are going to connect the corresponding edges. So from F to F dash, it will be the hidden line. So let us complete that. So F to F dash, it will be the hidden line. So it will be somewhat overlapping on the axis line, and then we'll draw the other outer edges. So from A to A1, similarly B to B1, it will almost overlap, and then from corner C to C1, and then from E1 to E, and then D1 to D. So all those edges will overlap. So this is the front view of the hexagonal prism with its axis inclined at an angle of 30 degrees but appears to be inclined at an angle of 41 degrees to the VP. So with this, we can complete the construction of the solution for the given problem statement. To summarize, we have got a hexagonal prism resting on one of its corner, and the two edges containing this corner, that is AF and AB, are making equal inclinations with the HP, and the edges of the prism measures 25 and the axis measures 50 mm. And in the second position, the axis is inclined at an angle of 40 degrees, and then in the third position, the axis is inclined to the VP at an angle of 30 degrees. But since the axis has changed its dimension from 50 to 38.3 mm, and we are going to consider this as the reference for the next position, we have to construct the beta angle, because the word appears to be inclined to VP is not mentioned in the problem statement. So the angle, beta angle, will be equal to 41 degrees, and then we are going to complete the construction of the top and the front view of the prism using the projection lines. Thank you.